Hello, everyone. We will be starting with the session now. Good morning, good evening, good afternoon. Dear authors and invited guests, welcome to the technical session 10B. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th February in London, UK, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 6 presentations, and each presenter would be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session. First, I would like to introduce you all to Professor Louis L. Numame. Sir is currently working as a senior lecturer at Oman College of Management and Technology, Oman. His research interests include artificial intelligence, artificial neural network, curriculum design, system automation, data security, and computational theory. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Thank you. Thank you for your presentation, for your introduction for me. I will, inshallah, hope all the presenter will enjoy that session and they present their paper in a very excellent way. Thank you.
Thank you so much, sir. So, I would also like to take a moment to introduce you to Dr. Prashant Hodo. Sir has more than 17 years of teaching and research experience. Currently, he is working as a professor in the Department of Information Technology of MIT School of Engineering in MIT ATT University. His publication includes more than 25 papers in the international conferences and journals. His research interests includes algorithms, privacy, and Turing machine. Welcome to the session, sir. Would you like to share a quick opening remark with us? Okay, I guess there might be some network issue. So now we would be moving towards the papers. First, we have Swastika Das to present the paper titled Bridging Digital Divide, a study on the Umang platform and its impact on e-governance. Are you there?
Yes, I'm audible.
Yeah, you're audible. You may begin with the presentation.
Okay. Are the slides visible?
Yeah, the slides are visible.
Okay. Thank you. Good afternoon, everyone. I'm Swastika Das, and it is my pleasure to present my paper on Bridging Digital Divide, a study on the Imong platform and its impact on e-governance at the ICICT 2025 conference. Today, I will discuss how the Umang platform contributes to e-governance in India, its role in bridging the digital divide, and the challenges and future opportunities it presents. The study is based on the analysis of the impact, challenges, and the potentials of Umang in making governance more accessible, efficient, and transparent. So let's begin. So this is the overview of the content. Before we dive into Umang, it is important to understand that what e-governance is and why it is crucial for modern India. E-governance is the use of information and communication technology to deliver government services effectively. It promotes efficiency, transparency, and accessibility in governance. So the key features of it are it enhancing public service delivery, reducing bureaucratic delays, and encourages citizen participation in governance. For the first time, e-governance was introduced in India through the National Informatics Center. And in recent times, it is through the Digital India initiatives, which was launched in 2015, that marked a major shift focusing on internet access, digital literacy, and online service delivery. And under this comes the role of Umang platform, which was launched in 2017, and it integrates over 2,000 government services across multiple sectors into a single mobile application. Its objective is to make government services available anytime, anywhere without requiring multiple app downloads or website visits. Now that we have understood what e-governance is, let's look at the Umang platform's overview. Umang platform is a key initiative under the Digital India that simplifies governance through digital solution. Its three important features are it is a mobile first approach, it has service aggregation and language accessibility. Almost 85% of Indians are using mobiles, and that is over 1.2 billion of them. So the government ensures that it's mobile friendly. Anywhere in any part of India, from remote, even a remote village, can access their government services through a phone without having to travel to a government office. It also focuses on bringing central and state government services together in one place. Like the users can access the Aadhaar updates, PAN services, Provident Fund tracking, and health records through a single interface. And finally, it recognizes India's linguistic diversity. Thus, it supports over 22 Indian languages, and any speaker from any language can access their details without needing an English proficiency. So these services are tailored to simplify all these complex processes. It covers almost most of the important sectors that is financial, healthcare, education, and agricultural. It has citizen-centric approach. Now let's focus on how Umang helps in bridging the digital divide. Despite India's technological advancement, a major digital divide exists between urban and rural population, and Umang plays a crucial role in addressing these gaps. They may be internet access rate, digital literacy issues, and language barriers. Only 37.3% of rural India has internet access. Thus, it might be a challenge for them to access all these mobile applications that government's providing them. And then there's a low digital literacy level, especially in rural areas who are unfamiliar with these digital platforms. And then most of these government platforms are more likely English centric, making access difficult for non-English speakers. Thus, Umang helps in including these people and addresses these challenges by providing them with language accessibility in over 22 languages. And the government has also led awareness campaigns to teach its citizens how to use Umang. And there are certain citizens who do not have access to smartphones. Thus, the government has also provided them with citizen common service centers where they can go and have access to these uh, devices. Now, let's focus on the impact. Umang has revolutionized governance by making public services more transparent, efficient, and citizen centric. So, two main areas are citizen participation and engagement and transparency. Citizens can now track application, file complaints, interact with government agency digitally. It has made their relationship more fluid. It has increased citizen participation in governance, and it also provides a feedback mechanism. So if anyone has any problem, they can directly lodge the complaints through the lab app. Next are the enhanced transparency modes. It helps in monitoring public services, and there are real-time updates. The citizens can get notification about how far the application has processed. And also it addresses public grievance redressal. So any citizens, they can file and track complaints related to government services. Well, despite its successes, Umang has some challenges that need to be addressed. First is the digital literacy barriers. Many users still struggle with digital navigation. Like elderly citizens may need assistance to access pension related services and other stuff. And there are citizens who are not familiar with all these applications. The second challenge would be data security concern. Handling of sensitive personal and financial data possesses cybersecurity risks. So, concerns about data breaches deter some users from adopting digital services. Then there are integration and interoperability issues. Like in at certain coordination issues exist amongst central, state, and local administration, and this is a complex procedure. They might be resistant to adopt these to be technologically consistent and in with the times. And there are certain states who haven't even fully integrated their services with the Umang at a national level. Well, addressing these issues is crucial to Umang's future success. Let's discuss their future direction. Now, to make Umang a truly national platform, several advancements has been made, like expansion. More and more government services are being added to it, and it has been a one-stop solution for all government-related queries. Then it has been integrating AI-driven innovations, like including voice-based AI assistant for citizens who have low literacy levels and cannot read, so they can speak in the regional languages like Hindi to check their government applications. Then measures have been taken to strengthen the cybersecurity aspect, enhance encryption and authentication, while also providing assistant mode so people who are at a greater disadvantaged position can access it. As I've mentioned earlier, there has been increase in common service centers also for better accessibility. So these future tools help Umang remain an inclusive and efficient governance tool. Finally, to conclude, Umang has transformed e-governance in India by making government services more accessible, transparent, and citizen-centric. It has bridged the digital divide through multilingual supports and mobile accessibility. There are some challenges, but it can be overcome with future innovations. So, thank you for your time. I look forward to your questions and discussions.
Thank you so much for your presentation, Swastika. So, do you have any questions?
I want to just to ask here one single question. How does that human gap compare with the global e-governance? Yani, we know that they have e-governance system platform. If we compare your model with that, with the e-governance model, what is the difference? What is the main feature in your model? Thank you.
Thank you, sir, for question. Well, it has been implemented at only on the national level in India, but it can prove as a blueprint for other countries to take up like create their own app where all the government services are integrated into a single mobile application. It is more accessible, and people don't have to go through all different bureaucratic levels, and we know that there are a lot of red tapeism in these functions, so it is easier for them to access it. And citizen it will also enhance in citizen participation. So it may depend on the government of different countries. If they find this app better, like a better perspective, they can adopt some of its features maybe. So maybe that can lead to a more global integration. I hope I've answered your question.
Thank you. Thank you.
Thank you,
Excellent.
sir.
Thank you. Congratulations.
Yeah. So, do you have any question?
I have one question. Could you explain me what are the other services that are already been added to Umang platform? Like any examples?
Yes, sir. So it has over 2000 services, but they can register for, or like they can register their vehicles, they can apply for driving license, and even all the e-hospital services like PM Jai, and there's Ayushman Bharat. And for students, they can access the National Digital Library through it. It can help us updating our PAN details, help us filing income taxes. And then mostly people use it for EPFO and accessing pension schemes like NPS and Atal Pension Yojana, and many more. It's endless. And different state governments have also implemented their own schemes or initiatives into it. So it differs from state to state also.
All right. Thank you.
Okay.
Thank you so much for your presentation. So, we'll be
Thanks.
moving on to the next presentation now. Next, we have SV Sangvi to present the paper titled Flexi Mind, Dyslexia Assessment and Aid Application for Specific Learning Disorders. Are you there?
Yes, am I audible?
Yeah, you're audible. You may begin with your presentation.
Okay.
Yeah, we can see your screen.
Okay.
Mm, I guess.
Good evening,
Screen
everyone.
is actually like blank. We can just
Yeah.
see.
Yes.
Great.
Good evening, everyone. Today we are here to present our research paper, FlexiMind, Dyslexia Assessment and Aid Application for Specific Learning Disorders. So first, let me introduce you all the three common learning disorders, dyslexia, dysgraphia, and dyscalculia. Dyslexia affects word recognition, spelling, and decoding, making the reading and writing difficult. Dysgraphia causes the writing difficulties, impacting the handwriting, spelling, and fine motor skills. Dyscalculia affects the number processing, making the math concepts and calculations challenging. So now let's focus on the problem. Tamil is one of the 17th most spoken languages in the world. So its complex letter forms and phonetic structures makes learning difficult for children with dyslexia and
I think there's no sound.
Sanvi, your connection, I guess, is unstable because we cannot hear you.
Yeah,
Uh, yeah. Can you please speak now?
Yeah. Now can you
Your voice is getting cut a lot. Vidya, your voice is getting cut a lot. We cannot see your screen running properly or your voice. Hello. Hi, Vidya. I guess your voice was not clear while you were sharing the screen. There's some kind of internet connection from your side.
yes, I guess now can you hear me?
Now we can hear you.
Yeah. Okay.
You may continue. Yeah. Please continue.
Thank you. So for the above mentioned problems, we are proposing FlexiMind. A solution focuses on Tamil letter learning, specifically designed for dyslexic and dysgraphic children. It integrates phonological processing with auditory, visual, and kinesthetic learning methods. Additionally, the math hand feature enhances the mathematical understanding through gesture-based interaction, making learning more engaging and accessible. So there are four key components in our system, that is dyslexia assessment, Tamil letter learning, math hands, word recognition, and sentence construction. So our literature review highlights the key gaps in existing tools. The HOPE and ICICT support the literacy, but it lacks the multilingual support and dyslexia detection. YALU diagnoses the learning disorders, but it also lacks the intervention. Dyscalculator and MATSHA aid the math comprehension, but they don't focus on dyscalculia. And Dyscalculic Kits is a system that is region-specific with limited adaptability. So FlexiMind takes a unique approach by integrating hand gestures and real-time feedback to support the dyscalculic learners, embodied learning by connecting motor skills with cognitive process, movement-based engagement to enhance the math comprehension, and Tamil language support, voice recognition, and interactive feedback, which is filling the gap in existing tools. This ensures an inclusive multisensory learning experience for children with specific learning disorders. So here's how FlexiMind supports the children with specific learning disorders. Dyslexia assessment evaluates the phonemic awareness, word recognition, memory, and speech articulation through interactive tasks. And Tamil letter learning components help the children with dyslexia and dysgraphia to master the Tamil letters by enhancing the recognition, pronunciation, handwriting, and literacy skills. Math Hand features uses the real-time hand tracking and image processing to create interactive math learning aids, engaging tactile, visual, and kinesthetic senses. Word recognition and sentence construction combines the machine learning with personalized exercises to address the dyslexia-related challenges in Tamil and English, providing the adaptive literacy support. So our initial evaluation shows that Fleximind has significant potential in supporting children with dyslexia, dysgraphia, and dyscalculia. The app's core modules have demonstrated a positive impact on cognitive and literacy skills, making learning more interactive and engaging. So Fleximind shows promising results across all 4 key components. First, dyslexia assessment enhances the phonemic awareness and visual spatial processing, improving the pattern recognition and Tamil pronunciation through speech recognition. Next, Tamil letter learning strengthens the handwriting accuracy and letter recognition through real-time feedback, helping the children to improve the fluency. Interactive pronunciation activities also there to reinforce the sound letter connection. Furthermore, MathHand uses the gesture-based learning to improve the number recognition and multiplication. Real-time feedback engages the motor skills, making the maths more accessible for dyscalculic learners. So at last, word recognition and sentence construction component enhances the reading fluency, sentence structure, and word recognition through personalized adaptive activities. Early results show the positive literacy in development with further validation in progress. So overall, Fleximind demonstrates a strong potential in supporting the children with specific learning disorders. So Fleximind offers a holistic learning approach combining tactile, visual, and auditory strategies to support the children with learning disorders. Its adaptable design allows the expansion to new languages and educational contexts, making it a valuable tool for educators, parents, and therapists. With ongoing development and refinement, Fleximind has the potential to become the indispensable resource for inclusive learning. In the end, our goal is very simple: to empower every children to learn, grow, and succeed. That wraps up our presentation. Thank you all for listening. So,
Thank you so much for your presentation. Sir, do you have any questions?
I just want to ask a question about different language, multi-language, to apply your model with multi-languages. How you can adapt your model to accept multi-languages.
So for different languages, we can train different models and connect that through the API to our application.
It cannot be one model for multi-languages.
Sorry?
The same model could not be for the multi-languages, cannot learn from
No,
multi-language at the same time.
Not the same model. We want to train different models. So for now, the CNN model was trained for Tamil language. And if we are integrating some more languages, we want to get some data on particular language and to train another model.
Okay, thank you.
Okay.
Thank you. Excellent.
Thank you so much. Sir, do you have any questions?
Yeah. So, have you done some ground truth about the model, like the testing? Is it just normal testing, like evaluation, or
No, we have tested the application with some children with learning disorders. In our country, we have some hospitals and clinics where the children with learning disorders come to consult. So from them, we have given an application and tested the results. And also, our application is tested by some psychiatrists as well. Yeah.
so? How was the result, and what was the reaction?
Yeah, like mostly it's giving the 83% correct results for the to improve their learning disabilities.
Okay.
Thank you so much for your presentation. We will be moving on to the next presentation. Next, we have Arjun Mehra to present the paper titled Investigating Behavioral Responses Across Landslide Scenarios in Virtual Reality. Are you there? Yeah, you're there. You may please begin with your presentation.
Hello, everyone. I am Arjun Mehra, a scholar at Indian Institute of Technology Mandi. I am one of the authors of the paper titled Investigating Behavioral Responses Across Landslide Scenarios in Virtual Reality. I would like to introduce my colleague, Mr. Ajoy Kumar, who will be presenting on my behalf, as I have small speech impairment issues. He is a fellow scholar that I had the pleasure of working with in the past year.
Okay, great. So you can share your screen and
Yeah.
begin the
Yes, ma'am.
presentation. He has some issues. So till the issues get resolved, you guys can let me know whenever the issue is resolved. Then we can schedule a presentation afterwards. Now let's move on to the next presentation. Yeah, that can work better. No, it's not a problem. We can just switch on to the next presentation till then.
Okay,
So next
excellent.
we have Akriti to present the paper title Multi-Level Hybrid Ensemble with Attention-Based Meta Learner for Diabetic Retinopathy Prediction. Are you there?
Yeah, hello. Am I
Yeah,
audible?
you may please begin with your presentation.
Yeah, just give me a second. I'll share my screen.
Yeah, please do.
Hi. Is my screen visible?
Yes, your screen is visible. You may begin now.
Great. Hi. So, the name of our paper is Multi-Level Hybrid Ensemble with Attention-Based Meta Learner for Diabetic Retinopathy Prediction. I will introduce you how what all we are doing under this. So, diabetic retinopathy or DR is a complicated disease which is caused by diabetes, which can lead to vision loss. Manual diagnosis is prone to human error and time consuming. And through this paper, we aim to propose a supervised learning approach using a hybrid ensemble of deep learning and machine learning models. The models used for deep learning is Inception V3 ResNet. And for classification, we have random forest and support vector machines. Along with this, we have an attention mechanism, which is integrated for more accurate classifications. On a broader level, this is our proposed methodology. The first level is the data pre-processing layer, which basically deals with data augmentations like mirroring, using mirroring and rotation. We have used SMART for class imbalances, and we have also included image resizing. The second step in our algorithm is feature extraction, for which we have Inception V3, where it focuses on broad features like shape, color, and variations of the fundus images. Now, the kind of data that we are handling right now is image data of the retinal fundus images. Now, the second thing that we handle for feature extraction is using ResNet. It handles the fine-grained details, more like microaneurysms and small vessels. We also focus on dropout and batch normalization for overfitting prevention. The next step would be classification and ensemble classification, for which we have used random forest and SVM. As you can see, the random forest is used for more high dimensional data, robustness, and noise handling. The SVM is used for more precise decision boundaries, non-linear classification, and make sure that we have ensemble for both robust classifications. The next layer to it is the attention mechanism, for which we are using LSTM as a meta learner. It dynamically weighs predictions and also focuses on relevant features like global or fine-grained in the fundus images of the retina. To make sure that we are able to understand our classifications better, we have a visualization using the GradCam analysis. It focuses on the affected area, and we also highlight regions of interest, which include exudates, hemorrhages, and also it helps doctors in more interpretations of the kind or the severity of the diabetic retinopathy that the patient is suffering from. Along with that, to optimize our results, we have hyperparameter tuning enabled in it, which focuses on learning rate, batch size, dropout rate, random forest. In random forest, we focus on estimators and depth. In SVM, we focus on kernel regularization parameters. And also we focus on the grid search and cross-validation. Now, for the data and pre-processing, the data is obtained from Kaggle, which has 30,000 retinal images, and the class imbalances addressed using data augmentation and SMART. The images are resized. Every image is resized to 256 by 256 pixels, and the mirroring and rotation is by 90 degrees, 120 degrees, 180 degrees, and 270 degrees. We are also using SMART, which is synthetic minority oversampling technique for the minority classes. Now, why SMART, you might ask? We're using it because the database is highly imbalanced with fewer severe DR cases. I would be using DR and diabetic retinopathy words interchangeably. Traditional models tend to be more biased towards majority class, which is no DR, and SMART synthesis new samples for minority classes, balancing the data set. Now, its relevance to our work includes it ensures that the robust learning across all DR severity levels is good. It improves the model sensitivity. It reduces any false negatives, which is something extremely important when it comes to more healthcare related algorithms. And then it's essential for accurate early stage DR detection, which is crucial in medical diagnosis. Now, LSTM as attention mechanism. So why LSTM? Because it's a traditional model. This traditional model equally weighs all features, losing critical details. LSTM dynamically adapts focus on relevant features and enhancing accuracy. Now, with respect to our work in this, it prioritizes fine-grained lesions for severe DR and broad patterns for mild DR. It also improves interpretability by highlighting significant regions using RADCAM analysis, and also boosts classification accuracy by context-aware predictions. It is also essential for nuanced distinctions in DR severity levels. These are some more finer details about the hyperparameter tuning and by what degree that we have tuned our algorithm. It has, if you see the learning rate, it is very precise. The precision is 0.0001 during feature extraction for stability and 0.001 during fine tuning for better adaptation. Similarly, for the dropout rate is 0.5 to prevent overfitting. And SVM and random forest parameters are 1.0 for non-linear relationships. And for in random forest, it's 100 estimators for max depth of 50. Now, coming to the actual deep learning models that we have used here is Inception V3 and ResNet. The Inception V3, it focuses on extracting broad and global features, like I mentioned earlier. It is also trained on ImageNet for generalized feature extraction. It captures well-delineated exudates and retinal structures used in ensemble for high-level pattern recognition. For ResNet, it extracts fine-grained details. It skips connections, prevent vanishing gradient by enhancing learning. It captures minute lesion crucial for severe DR classifications. And at the same time, it complements Inception V3 by focuses on intricate features. We found that the combination of Inception V3 and ResNet was very good, due to which we got an accuracy of 89%, which seems to be quite good for more medical related diagnosis. Now, for the machine learning models that we have used here for classifications are random forest and SVM, support vector machine. The random forest, it handles high dimensional data without overfitting. The ensemble of decision trees with majority voting for classification. It's robust against noise and imbalance in the data set. It ensures generalization across varied retinal image features. On the other side, support vector machine or SVM, it creates precision decision boundaries for classification. RBF kernel used for non-linear feature separation. And it is effective in distinguishing subtle differences in DR severity. So in this, we have multiple classifications of DR, which is no DR, mild DR, severe DR, proliferated DR. So basically, a combination of these two, and especially SVM, helps in the subtle differences in the DR severity and identifying and classification of it. It also complements random forest for refined classification. So the combination of this again was working very well in terms of accuracy, F1 score, and the overall performance of the model. So if we see the final classification after the deep learning and the machine learning ensemble models are used, the final classification is that the output is combined using the LSTM meta learner, which is an adaptive weighing for context-aware classification. And here you can see the results. The overall accuracy is of 89% for the proposed model. The deep learning ensemble achieves 87.1 accuracy. And through the machine learning ensemble alone, it achieves 85% F1 scores. The GradCam provides interpretability by highlighting important regions. And through this, the error analysis showed challenges in detecting early DR signs. Overall, what we focused on was to make sure that through all the work that we have done on this, that the robustness of the model, the correct classification, interpretability, visualizations, all in all work in favor of the doctors and the healthcare providers and make sure the diagnosis is as accurate as possible. In the future work, we are planning on enhancing on data augmentation and hyperparameter optimization for more clinical validation. In few sentences, if I were to say the study basically proposes a hybrid ensemble model for automated diabetic retinopathy detection using the deep learning and machine learning. It integrates Inception V3 and ResNet for feature extraction, random forest and SVM for classification, and an attention-based meta learner for improving accuracy. And later on, it then uses GradCam for more interpretability. Our study bridges a gap by integrating a hybrid ensemble approach with a more attention-based meta learner, which improves not only the accuracy and interpretability, but as we compare it with the more existing studies, the current existing studies, they focus on more deep learning or machine learning individually, whereas our study combines both of it, and we uses each one for either for feature extraction or for classification to get a better result.
Thank you so much for your presentation. Sir, do you have any questions?
Yes. I just want to ask, what is the key challenge you can deploy in your model at the clinic? How we can use it at the clinic?
The key challenges that we encounter.
Yes.
Okay.
When we use your model in a real clinic.
So in general, one of the major challenges overall in clinics was to understand the granularities of the DR detection. That in particular was one of the challenges that we wanted to resolve through our research work. The challenges that this was a challenge we focused on when it came to the diagnosis and something that we wanted to resolve. When it comes to the challenges we faced during the execution of the entire thing was handling class imbalances and optimizing computational resources for training large-scale image data. Because since it's image data, we wanted to make sure that there is for which we have also used SMART and LSTM. Basically, we have processed pre-processing data. We made sure that the image data is normalizes well pre-processed, so that the computational resources for training that is optimized, and the interpretability of the model predictions also are taken into consideration.
Thank you. Thank you.
Thank you so much. So do you have any questions?
Yes, I have few question about this. So one of the major question that I have is about the hyperparameter. I think I've seen you have mentioned a few hyperparameters about learning rate. Then for the random forest, you have mentioned max depth equal to 15, and the leaf I think it was around 100. So these parameters are how you came up with that these are the best parameter that will work for this model.
Okay. So with respect to tuning our model using these specific hyperparameters, uh, we found that a combination of the parameters that we were working on, um, and our guide also who helped us in this research, we would there was a lot of trial and error, and a lot of understanding of the data that we were working on to make sure that the results were as accurate as possible. The combination of these particular hyperparameter tuning seemed like turned out one of the best that we could find in terms of computational resource usage, and also the results that we were getting. So it was a lot of experimentation, a lot of computationally, and the final decision classification wise result that sort of helped us understanding um, which parameters were working better in terms of this.
Okay, and what is the computational power that you have used for this training?
Computational power. One second, let me just confirm.
As in GPU or any HPC units like high performance computing?
Yes. So for training of the large image data, which was again another challenge because it takes a lot of space and a lot of time for processing, we were using batch processing and GPU acceleration.
Okay.
Thank you so much for your presentation. So we'll be moving on to the next presentation now. We'll continue with the presentation. We have Arjun Mehra to present the paper titled Investigating Behavioral Responses Across Landside Scenarios in Virtual Reality. You may begin with the presentation now.
Yeah. Thank you, ma'am. And
Yeah,
I'm try to share my screen.
yeah, please share your screen.
Yes, now it's visible. Can you confirm me, ma'am?
Yeah, yes, your screen is visible. You may begin now.
Okay. Yeah, a very welcome to everyone to this presentation, investigating behavioral response across landslide scenario in virtual reality. This is a collaborative work done in Applied Cognitive Science Lab in Indian Institute of Technology, Mandi, India. Landslide is a major and global hazard that we are all facing in many areas, and it create infrastructure damages to the life, and this is triggered by any natural factor like heavy rainfall, earthquake, and human activities. So these are very unplanned, due to the very unplanned construction, deforestation. Landslides are unpredictable and difficult to manage. Traditional training method rely on static models and lack real-world interactivity, reducing effectiveness. Here, the VR-based simulation provide immersive a risk-free environment for studying human behavior and cognitive responses. Behavioral data like number of collision, velocity, equilibrium distance, access, navigation, and decision-making abilities. So all the previous the training processes are rely on the very static model, and they are not very interactive to to judge the user decision making in that scenario. So in this paper, we have explored these two objectives to examine the behavioral responses like the collision, the velocity in varying landslide risk and condition. And second, we have developed a VR-based simulation to enhance disaster preparedness training. The experimental designs consist of four conditions: high landslide with risk of 80% probability, low landslide risk at 20% probability, and lighting condition to day and night. We have collected the behavioral data, that is Euclidean distance from the landslide point. We have collected the collision number of landslide occurring and the velocity from the position and the data in the simulation. We have done this study with a total 80 healthy participants. Their age ranging from 22 years with a standard deviation with 1 year. The gender distribution is 60% male and 40% female. Their education background, they are all from science and engineering background, and the data points are collected from Indian Institute of Technology, Mandi. The age is above 18 plus, and they have signed their consent and they are participating in voluntary. The procedure, we have collected the pre-experimental setup data, like the simulation was tested with a Unity engine, and participants were instructed on the working of hardware via headset and steering wheel. So basically we have used this VR simulation and a steering wheel for this study. The simulation was developed in Unity engine, and this hardware we have used to driving in the VR simulation condition and the situation. The simulation, the simulation and the task, that is that they need to drive safely with this day and night condition and with low and high landslide probability. So our main objective to navigate safely end of the road while avoiding landslide collision. We have collected this data using the C# script compiled in the Unity itself. We have also accessed this post-experiment assessment. So this is a pre and post data collection, and we have analyzed the data in pre and post. Here we can see there's two pictures. One is the subject that is using the simulator in night mode, and a view of the participant day mode with high risk of landslide. We have collected this behavioral data, including equilibrium distance, the deviation from the center of the road, the collision count, which is the number of collision during the driving, and the velocity around collision, which is the average velocity around the interval of the landslide, which is before or after this is 2.5 seconds around the landslide point. We have done this statistical test with ANOVA test to study the group comparison and the across the groups and the condition, which is the landslide probability and the light condition. Here we have the result. In high probability scenario, which is 80%, we got increased equilibrium distance, collision frequency and velocity around collision. In the light condition, there is no significant effect observed in the day and night. For the equilibrium distance around the collision, we got the F statistics 13.30 and a significant p-value. Number of collision, we got 18.17, that F value, and a significant p-value. The velocity around the collision, we got F statistics value is 16.26 with a significant p-value. We can also see in the graph that the difference between this collision condition with high probability and low probability condition along the equilibrium distance around the collision, number of collision, and velocity around the collision. The conclusion we can conclude from this study and this behavioral analysis, this high perceived risk increase behavioral deviation. There is no significant impact on the light on behavioral response. We can conclude that this VR simulation training can make the participant more preparedness to the landslide scenario. We can make it more training processes for the learning, and how we can manage the landslide scenario in the driving scenario. This future work may consist of taking more physiological neurological data like EEG, HRV, and some biometric data to gain deeper insight into the stress and the decision making perspective. We can expand this experiment factor, like we can add some rain, fog, thunderstorm to increase the ecological validity. We can do this study in long term with respect to time to make it more longitudinal studies. We want to acknowledge National Mission on Himalayan Studies, this project under Dr. Varundar sir, to provide this facility and the hardware and the lab space of Indian Institute of Technology. Thank you, and if you have any question, please feel free to ask me.
May I have a question?
Yes, yes.
How we can compare your virtual reality reaction for that cases with the real disasters reaction? You can find some methodology to compare, some method to compare between the reality and your modeling.
Yes,
Do you
yes.
think about that?
Yes, yes. So the literature says the all there are some model there are some training which are given to the landslide areas, the people, and they are not they are rely on very static manner. So what we have done, we have created that virtual reality based landslide scenario, and we tried this to drive a car in this simulation, and try to figure out what's actual their decision making. So the all the previous studies that are given, they are not doing it in virtual reality. So we are trying to make a novelty here, that we have tried this environment, virtual environment, with this steering wheel scenario to know user understanding or user decision making.
Yeah, this is Professor Dutt. Just wanted
Excellent,
to
thank
add to my student's answer, if you can hear me.
Yeah, please.
Yeah, so your question is very well taken. Actually, the landslides are life-threatening problems. Our campus is located in a landslide area. We have rock falls and disasters happening all around us during the rainfall. But putting people through a real simulation is really problematic. So VR is kind of a safe, controlled environment where we can see the reactions. But we do see a lot of deaths and injuries happening and fatalities happening due to landslides in our area. We are in the Himalayan mountains. Yeah. But good point. It's very challenging to compare with the real
Yeah,
world here. Yeah.
that's excellent. Thank you. Thank you. Thank you for
Thank you.
both of you, you and your students. Thank you.
Yeah,
Thank you
thank you.
so much. Sir, do you have any questions?
No questions.
Thank you. So we'll be moving on to the next presentation. Thank you so much for your presentation. Next up, we have Nadia to present the paper titled Semantic Segmentation of Buildings Using Optical Satellite Images and Deep Learning. Are you there?
Good afternoon.
Yeah, you may please begin with the presentation.
Yes. Good afternoon, everyone. My name is Nadia Liz Gispesiancas. The title of project is segmentations of building using optical, satellite images, and deep learning. Introductions. Building segmentations in urban area using satellites, imaging, and deep learning is key in remote sensing and artificial intelligence. Accurate building detection is essential for various applications, but manual images interpretation is slow and error-prone. Deep learning, essentially a convolutional neuronal network, has proven to be an effective solution, allowing the automatic extractions of relevant fixtures for building identifications. Related work, we can mention too the study applied semantic segmentations for vegetations, monitorings using deep learning, evaluating three models, UNet, ResNet, and SecNet, on dataset big nets and MODIS. UNet achieved the highest accuracy, 91%, followed with ResNet 74% and segment net 21%, demonstrating the effectiveness on different architectures of vegetation analysis. The method is proposed to automatically extract building footprint in high resolution satellite images with the SpaceNet dataset, using with UNet with data augmentation and post processing, achieving an one score on 17%. Proposed method. The methodological approach of these studies focus on the applications on advanced semantic segmentations, a technique for property using high resolutions satellite images with data source from the Perusat-1 satellites. There is utilize deep learning tools and frameworks, include raster vision, Python lining, and UNet, to analyze and classifying elements of the terrains, assessing the accuracy and efficiency of each in property segmentations. Collection. The dataset contains a large panoramic RGB images of the city, captured in the Juanjuy district, Mariscal Cáceres province in San Martín, Peru. Its main object is to enable the segmentations of house geospatials. Imagine using advanced image analysis techniques to identify and delimited residence structure in urban environments. Labeling in shapefiles for semantic segmentation of geospatial imaging is a fundamental process in spatial data analysis, as it allows for assigning semantic labels to different objects or features present in these images. In the space case of the dataset labels in QGIS, this geographic information system was used to carry out the labeling process of regions of interest. Training model. Training model for semantic segmentations uses key technologies such as raster vision and lining, Raster Vision is an open source platform for analyzing raster images and classifying objects. What Lightning simplifies model designs and training with reusable components. Several advanced models are employed in semantic segmentations, each offering unique advantages. DeepLab V3 ResNet 50 integrates to capture intricate feature enhancing segmentation precisions. FCM ResNet 50 adapts the fully convolutional network with ResNet 50 to generate high quality segmentations mass efficient. DeepLab V3, MobileNet V3 strikes a balance between accuracy and efficiency, making it well suited for mobile applications. Efficient nets layers bitwise separable convolutionals and composite scaling to optimize efficiency and performance. ResNet 101, a deep 101 layers CNN with residual connection, facilitating improved learning in deep architectures. UNET, what leads used model design for semantic segmentations, features an anchor decode structure for efficient feature extractions. Uh, Training and inference die are keys to assess the efficiency of model. Training time varies depending of the complexities of the models, while inference the measures how fast it is making predictions. It was observed that UNET required less training time and DeepLab V3 Mobile V3 in inference, FCM ResNet 15 showing better performance, being faster than DeepLab V3 Mobile V3. The purpose of training models like UNET and raster vision with Lightning is to optimize performance. Experiments and results. UNET, raster vision, and Lightning models were trained for 100 epochs in an interactive environment with Jupyter Notebook, allowing real-time analysis and optimizations. Performance evaluation was performed using F-score and accuracy. The study evaluating multiple deep learning models for geospatial image segmentations, comparing their performance based of F-score and accuracy. FCM ResNet achieved the highest accuracy, 83.56%, and F-score 83.64%, making it the most precision models. DeepLab V3 ResNet 50 follow closely with a F-score of 83.33% and accuracy 83.34%, demonstrating a strong segmentation capability. DeepLab V3 Mobile Nets V3 delivered acceptable performance with a F-score of 74.28% and accuracy 74.14%. Meanwhile, UNET reached 74% accuracy, while efficiency V0 and ResNet 101 show lower performance with F-score 56.64% and 47.0%. Six deep learning models, DeepLab V3, Model V3, DLAB V3, ResNet 50, FCM, ResNet 50, Efficient V0, ResNet 101, and UNet were evaluated for property segmentation accuracy. The performance of each model was assessed using a validation dataset with results present in the images. Conclusions. The study revealed variation in the performance of deep learning model for building segmentation in suburban satellite images. FCM ResNet and DeepLab V3 ResNet 50 achieved the highest accuracy, exceeding 83%. Studying for their efficiency, DeepLab
Interrupt.
V3 Mobile V3 and UNEP obtained competitive results with accuracy close.
Interrupt you, but you have 2 minutes to conclude your presentation.
Thank you.
Thank you. Thank you so
Thank you.
much for your presentation. Sir, do you have any questions?
I have one question about low resolution images. How your model will treat that type of images? How you can construct the features from such type of images with low resolution? Not always we'll get very high resolution images. If your model get low resolution image, how we can construct or build that features and how its accuracy in that case?
Data set is images of the city captured in the satellite Perusat in the Huanhuin district of Peru.
No sound, please. There is no sound.
We can hear you, sir. I guess there is some problem from your side, some network issue. Okay. Sir, do you have any questions?
No questions.
Okay. So we'll be moving on to the next presentation then. Next up, we have Ambrose to present the paper titled UAV Image Motion Deblurring Methods in Precision Agriculture, a bibliometric analysis to a short survey. Are you there? Ambrose, are you there?
Yes, good afternoon. How are you? Thank you very much for your attention. Okay,
Yeah,
I will present
yeah, you can
quickly my,
present the- yeah,
yes, no problem. I'm
you can
coming.
present the screen and start
Yes,
with.
yes. Just a minute so that to show my presentation. My presentation now?
Yes, we can see your presentation. You may begin now.
Okay, thank you very much. Good afternoon, everybody. Good afternoon, the member of the conference. My name is Fujisi Ambrose. I'm from Benin, and I'm presenting the UAV image motion deblurring method in precision agriculture, a bibliometric analysis to a short survey. Okay. So my work will go through. First, I will present an introduction. Then I will explain the methodology of the work. Then I will present a bibliometric analysis. I will talk about the short survey, and I will finish by a conclusion. Okay, so precision agriculture involves timely acquisition of analysis and of farmland and livestock information. remote sensing via remote sensing via unmanned aerial vehicle is remote sensing via unmanned aerial vehicle acquires images with altitude and mobility. So images are often blurred and usually error prone in precision agriculture. Motion blur is caused by camera shake, atmospheric turbulence, operation errors, fast motion or irregular deformation of agricultural organisms, motion or shifting of agricultural organisms. Image deburring is a greater challenge for applications such as plant phenotyping recognition, crop pest and disease detection, animal behavior analysis. So two categories of image motion deblurring techniques. We have blind and non-blind techniques. Each technique classifies either as traditional or deep learning based. Several techniques has been developed to address motion blur in UAV images, such as opening thus new direction in computer vision research. But the breadth and depth of their use in agriculture are still narrow, and modern image motion deblurring algorithms have many limitations. To make significant contribution, we need to have a good overview of the research already carried out in this field. So we need to do bibliometric analysis. So bibliometric analysis needed to analyze and map scientific research to identify and quantify collaboration between different authors, to include the choice of research topic, to influence the funding of scientific research. So our bibliometric study on UV image motion deblurring method in production agriculture, we apply it to precision agriculture, the limitation and how to improve the performance. So we, through our work, we have identified annual scientific output, the most productive authors, countries and journals in this field. And we follow our work, our bibliometric study by a short survey to explore current research work focused on improving the performance of UV image motion deblurring method in precision agriculture. So, ladies and gentlemen, through our bibliometric analysis, we first of all start by a research string, then we select a database, and then we define the criteria of research, and then we select tools. So one research string defined in our work was crop or pest or disease or plague, and UAV or drone or unmanned and aerial and vehicle and image and color or correction or contrast or enhancement or feature or extraction or segmentation or annotation or motion or analysis or pre-processing or onboard or real-time or algorithm or approach or noise or defect or plant or detection or identification. So through performing our research string, we retrieve 2,162 papers. One database has been then selected through Scopus database. Two criteria were defined. The search is extended from 2014 to 2024. Analysis was limited to publication in English. We use these three additional tools we use 3 tools exactly, which is bibliometrics for Air Studio, and then Biblio Shiny, and finally Excel, Microsoft Excel. So through our bibliometric analysis, you can notice that the researcher has increased from 2012 to 2017, and then from 2017 to 2020, 2019, the increase continued. And by 2010, there is the virus of COVID, which decreased the research. And research has continued from 2021 up to then. So the research show sustain and significant growth over the years, reflecting growing interest in and investment in issues relating to UV image motion deblurring method. Our study suggests that image motion deblurring method are maturing with a focus on improving performance. Our study allows us to confirm the growing interest in research around the study topic. Our study allows us to predict more work and publication on the subject, and more particularly on the performance of optimization of image motion deblurring methods. Secondly, we have also studied the most relevant studies, which reveal the top 3 among the most relevant sources, such as remote sensing, computer and electronic in agriculture, Nongye, Gongsheng, Suibao, the cross-analysis and IHNDES in publication volume provide insight into the influence and productivity of these sources. We also study the most relevant authors. So as most relevant authors, we have Nyang Ji, we have Su Wai, we have Lopez Granados, we have Torres Frances, we have Peng, and we have Li Zi. They allow us to hypothesize that continents such as Asia, Europe, and America are the most involved in subjects related to UV image motion deblurring method and the performance. So as you can notice, the most relevant countries are as follow. China is consistently the China consistently sent out the leader, and followed by USA. And in third position, we have Spain, which has a strong and growing presence, particularly in the more specialized research on the field. Is an error, excuse me. And finally, we have Italy. Okay, so I'm working on image motion deblurring techniques, UAV image motion deblurring techniques. So low level of activity of African countries in this result are poorly represented. There is a need to increase the investments, capacity development, and participation of African research in this promising field. As a short survey, you can notice that application of image motion deblurring techniques are as follow. There is, first of all, plant disease and pest detection, in which the deblurring technique can enhance the visibility of small-scale features on plants, making it easier to detect early sign of disease or pest. Clearer images contribute to more accurate classification of plant health indicators, facilitating early diagnosis of disease and pest. Secondly, we have plant phenotyping, which is characterized by high resolution images, in which high resolution images are essential for extracting detailed phenotyping information. We have also weed detection, for which accurate weed detection benefits for clear image to distinguish between crop and weeds. Fertilizer spreading, for fertilizer spreading in the fourth step deblurring enhances the precision of assessing the distribution of fertilizers. We have also fruit sorting and grading, for which clear images are crucial for accurate sorting and grading of fruits based on size and quality. Finally, we have precision livestock farming, for which clear area imagery aid in monitoring livestock and the environment. As a conclusion, we can say that the most impactful offers, the most impactful offer has 53 publications. The most impactful journal is remote sensing, whereas China is the country with the most impactful production. Throughout our survey, it is essential to consider the specific requirement and constraint of precision agriculture application when choosing a deblurring technique for UAV imagery. Factors such as real-time processing, computational efficiency, and the level of accuracy required from the analysis should be considered. Additionally, the choice of method may depend on the specific characteristic of the UAV platform and its imaging system. Overall, this review provides a concise overview of UAV image motion deblurring techniques, the application in precision agriculture, challenges, and future directions. It serves as a valuable resource for researchers, practitioners, and policymakers involved in the integration of emerging technology in agriculture. So we have a certain number of offers which have been mentioned by the till the end. So thank you very much for your attention, and I'm okay for understanding your question, and thank you very much.
Thank you so much for your presentation. Sir, do you have any questions?
I have one question for our dear presenter. What about when we have varying environment conditions like wind, lighting change, clouds? Do you think your system will work with such type of change at the climate
Please,
for Purdue?
excuse me, can you take again? I can hear you very difficultly. Can you take again, please?
Okay, no problem. What do you think? How your system will behave, especially when we have the changing at the environment conditions, like changing at the wind speed, the lighting degree. Sometimes we have different lighting. We have clouds. We have shadow. How is your system will deal with this such type of changing at
Okay.
the climate, at the environment?
Okay, thank you very much. Sir, we are using UAV because UAV is a flexible remote sensing terminal which can be used more effectively than satellites. Even if there is rain. When there is rain, it's not good to use UAV, but it can be more flexible than satellites. In the past, satellites are the remote sensing, the remote sensor which are used for this kind of application, precision agriculture, and other fields. But for now, we are using UAV, so that will be more. UAV is more is lower in terms of cost. It's cheap compared with satellite. UAV can easily be flown over a field, okay, so that to take real images, and it can be flown very near to the plant plant leaves, and so that to take concrete images so as to easily detect the different the different disease and the crop the pest which is inside uh, the the leaves. Okay, so UAV has been more and more used nowadays because they are more flexible. They are not cheap. They are not expensive as satellites, and you cannot use UAV in bad environment condition. There should be sun. Huh? There should be by the night. You cannot use UAV, but you can use it when times are clear. Uh, uh, in terms of wind, yeah, you know, good in wind condition. When there is wind, you don't need to use UAV. UAV is more effective in condition without strong wind. I don't know
Thank
if
you. It's now clear for me. Thank you. Thank you for your answer.
okay.
So
Do
much.
you have any other question?
Yeah. Do anyone has any questions? So
Not a question, but just one suggestion. In case of UAV, so if the agricultural land consists of canopy-like situation, let's just say the vineyards. So I think there will be a problem with the altitude because the UAV won't be able to go between from the canopy.
Please, can you take again? I'm hearing you very. I didn't hear you well. Please, can you take again once?
So I was making a suggestion in case of vineyards. So this may be a problem for UAV to go under the canopy. So the vineyards, right?
Um, the, uh, your question, very. Yeah, I have an issue in understanding exactly.
That's all right. No worries.
Can you take a last time again, please?
Yeah. So in France or in India, there are vineyards.
Yes,
Uh,
yes, yes,
yes,
yes.
yes. So
Understand? Yes,
vineyard, there is a canopy. So
yes,
there
yes,
will be a problem for this UAV to go under or be below those canopy because of
yes,
the
yes.
altitude problem.
Okay, I understand. Okay, so you are asking how I can manage.
No, no, no. I'm just suggesting that this will be a problem.
Okay, okay, okay. Thank you very much. Yes, UAV being more flexible.
It's all right. You don't have to answer. It's all right. No worries.
Yes. Okay. Yes, I understand, but that's why we are applying to precision agriculture. Me personally, I'm working on maize leaves. Huh? So we are supposed to go through maize field so that to find the different diseases and pests which are uh, um, which may have attacked the leaves. Okay, so we are not applying our work to trees. So I don't think. Do you understand my
thank you
Thank you.
more?
Time, please. We have
Yes,
another
yes. Thank
session,
you.
please.
Okay. Mm,
so
okay.
much for your presentation. I truly appreciate it. Now,
Okay.
I would sincerely like to thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this 10th version of the conference and all the previous 9 versions as well. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and further, all the papers have already been forwarded to the Springer. The publication would be live within 6 months, so kindly cooperate with the team of ICICT 2025. Before ending this session, I would like to take a moment to thank our session chair, Professor Louis, for chairing this session. Thank you so much, sir. Would you like to
Welcome.
share a quick closing remark with us?
Yeah, I have recommendations for the author of these papers, of this research, the researchers. We'd like to clearly outline how your research contributes to the technologies, advantage of the new technologies, especially at the social life, social benefits for human. Yani, always we should put a point at the conclusions of our research, how it is will affect the life, how it is benefit for our lives. This is one point. Also, uh, how to implement these researches at the real world. We should think about that. This should be one of our main research purpose. How we implement the research really at the real world. And thank you. Thank you for all.
Thank you so much for chairing this session. I would also like to take a moment to thank Professor Prasad for chairing this session. Thank you so much, sir. It is a token of appreciation to the chair on the behalf of whole team of ICICT 2025 and Global Knowledge Research Foundations and partners. We would be really glad if you could share a quick closing remark with us.
Thank you for the allowing me to be the chair person for this conference. I agree with Professor Loe as well. So we have to focus on the the application part more and how it would benefit the society. There were very great presentations, especially the landslide one. So I think the demonstration, if it could be mapped to the real world problem and scenarios, that could be a very nice application as well. Thank you.
Thank you so much, sir. So before ending this session, I would like everyone to kindly turn on their cameras for a quick snapshot.
Please, can you take again, please?
Yeah, can you please open your camera for a quick snapshot, all the presenters?
Okay. Thank you. No problem.
That's
Yes.
yeah. So I'll be clicking a picture. Thank you so much, everyone. Stay safe. Take care. Thank you.
Thank you.
Thank you. Bye-bye.
Thank you. Thank you.
Okay. No problem.
Thank you so much, everyone. Bye-bye.
Okay, you're welcome.
Have a nice day.
Have a nice day.
Thank you. Same to you.
Same to you. Bye.
Thank you.